Welcome to Prince Expository YouTube channel. In this video, we will learn about gate trains. The combination of two or more gears meshing with another to transmit power from one shaft to another is called a gate train or train of toothed wheels. A gate train is two or more gears working together by meshing their teeth and turning each other in a system to generate power and speed. A gate train consists of any or all kinds of gears like spur gears, bevel gears, spiral gears, etc. These gate trains are used when a large velocity reduction is desired, and also the distance between the two shafts is neither too high nor too shafts. Types of gate trains. The following are the different types of gate trains depending upon the arrangement of wheels. First one, simple gate train. Second one, compound gate train. Third one, reverted gate train. And fourth one, epicyclic gate train. Simple gate train. Each shaft carries only one gear. Such gate train is called as simple gate train. It is represented by their pitch circles. When there is only one gear on each shaft as shown below, and also when the distance between the two shafts is small, then simple gate trains are preferred. In the animation that is shown below, let us consider the brown color gear as gear 1 and blue color gear as gear 2. The gear 1 drives the gear 2, so the gear 1 is called driver and the gear 2 is called driven or follower. In this case, the motion of the driven is opposite to the motion of the driver. For this animation, let us learn about velocity ratio or speed ratio. It is defined as the ratio of speed of the driver to the speed of the driven or follower and is equal to ratio of number of teeth on follower to the number of teeth on the driver. So therefore from this definition we can write down velocity ratio or speed ratio as speed of the driver divided by speed of the driven. Therefore, finally, we can write speed ratio is equal to n1 by n2 is equal to t2 by t1. There is another concept in this simple gate train that is about the train value. The train value is defined as the reciprocal of the velocity ratio. That means train value is equal to 1 by velocity ratio. When the distance between the two gates is large, the motion from one gate to another can be transmitted by one or more number of idle intermediate gates. Now showing you in this slide all the possibilities that include intermediate gates or idle gates in the arrangement. So idle or intermediate gates are used to bridge the gap between the driver and the driven. Also, idler is used to change the direction of the motion of the gears. If the number of idle gears are in odd number, then the motion of the follower will rotate in the same sense of the driver. If the number of intermediate gears are in even number, then the motion of the follower will rotate in opposite direction of the driver. Now, if you look at the first animation in this, it is a simple gear train with two gears, brown color gear and blue color gear as explained before. Now look at the second arrangement in this animation. There are three different types of gears. Gear A is in blue color, that is called the driver. Gear B is in red color, that is called idler gear or intermediate gear. and gear C is in blue color. It is called driven gear. Now, if you observe, the driver gear A is rotating in anti-clockwise direction, and B idler gear, which is in contact with gear A, takes opposite sense. That means it rotates in clockwise direction. And idler gear B is also in contact with driven gear C. Thereby, because gear B and gear C are in contact with each other, when gear B rotates in clockwise direction, gear C rotates in anti-clockwise direction. Now observe very carefully. We have only one intermediate gear in this arrangement. That is the reason driver and driven rotates in the same sense. Now if you look at the third arrangement, four gears are seen in the arrangement. Among the four, the bigger one is called the driver, and the smaller one towards the man is called the driven. And two gears that are kept in between, mounted on the single shaft, those are called intermediate gears. Now, in the third arrangement where the man is standing, two is an even number. Two intermediate or idler gears are kept in this arrangement. Now, if you observe, the driver, that is the big gear, is rotating in clockwise. First intermediate is rotating in anti-clockwise. Second intermediate is rotating in clockwise, and finally the driven is rotating in anti-clockwise direction. That means the number of the idle gears decides the sense of the driven.